Oh, grabe. Oh Lord, thank you so much. Now for the calculation continuation of the problem solving. Okay, this one. So this is the problem a while ago that I stopped. Naputol siya. Okay, so try to solve this one out. This is thermodynamics problem. Hey guys. Okay, this is the solution here. Okay, demonstrate this first. A car tire conditions of 0.0380 cubic meter of air at a pressure of 2.20 times 10 to the 5 Newton per square meter above 32 psi. How much more internal energy does this gas have in the same volume as at zero gauge pressure, which is equal to normal atmospheric pressure? Solution. Okay, here. So this is not isovolumetric or isothermal thermodynamic process. Okay, this is not also isothermal process. Okay, this is not also isobaric process because volume and pressure are given. Okay, and then internal energy is being asked. So if it is an isothermal, the internal energy is zero. Okay, so it's being asked. So that means this is not an isothermal. Okay, so this is not also an isolated system because in isolated system, both Q and work is equal to zero. Okay, so we're using this equation. Delta U is equal to Q minus W. So we are trying to adopt the adiabatic process. There's no heat flow. Okay, so there's no heat flow in the adiabatic process. Q is equal to zero. Heat energy is equal to zero. So the U is equal to negative W. Okay, we have the volume. Okay, we have the pressure 1, and we have the pressure. Okay, this one. We have this one equation, adiabatic process. So delta U is equal to Q minus W, then delta U is equal to negative W, right? Change in internal energy is completely used up by the work done by the system. Okay, so in adiabatic process we have W is equal to negative N CV delta T. Okay, and then substitute that in this equation here. Delta U is equal to negative W. So the signs will be cancelled out. So what remains is the delta U is equal to N CV delta T. Okay. So since this is a car tire and what's inside a car tire is the air, so we try to have an assumption that this is an ideal gas. So we have P1V is equals to N1RT. Okay, P2V is equals to N2RT. Why? Why we did not use the Boyle's law, Charles' law, Gay-Lussac's law, or the Dalton's law of partial pressures? Okay, because this involves number of moles here. See, internal change of energy as well. Change of internal energy of moles here. So it also a combination of formulas that have N also, so which is the PV and RT, not the Boyle's law, Gay-Lussac's law, the Charles' law. Okay, now so okay, so N1 will be P1V over RT. N2 is equals to P2V over RT. Something like that. Okay, so the next step is this one. So the value of N1 is P1V over RT and over N2 P2V equals to RT because we need to have ratio for both number of moles of the two systems. Okay, because we have two pressures given here. Okay, something like that. So, N1 over N2 is equals to P1 over P2 na lang siya because it will cancel the P and R2, PR2 like this. Okay, now we have the delta U is equals to NCV T na lang